So looking today at quadratic models. Now, a quadratic model describes a practical situation using y equals ax squared plus bx plus c. Now, we've seen previously that this equation is the graph of a parabola. So what makes this the graph of a parabola is that the highest power of x is 2. So where we have a linear equation where something might be y equals mx plus c, okay, that's where x has no power at all. So we've seen that's a straight line. And we've also seen y equals a to the power of x, which makes an exponential graph. All right, so basically what's happening with the x in an equation determines the shape of the graph. So this is how you know what shape it makes. When you can see that x is squared, you know it's called a parabola. So looking today at practical applications of that. Now, the most common application is going to be the maximum or minimum area of a particular thing. Quite often garden beds or fenced rectangles. Okay, so if we have a look at our example here, we've got the area A of a rectangular garden of length x meters is given by A equals 6x minus x squared. So that is the equation that we're working with today in this example. Now you can see the highest power of x is 2, but you'll also notice that it's a negative x squared. So thinking back to what we've seen before, y equals x squared, that's concave up, or our smiley face parabola. Okay, y equals negative x squared is concave down, or our frowny face. Okay, so positive for smiling, negative for frowning. Concave down. So what this tells us, because x squared is negative, it means our parabola is going to take that shape. Okay, so we've given a table of values here which we need to fill in using our x values that we've already been given, okay, and determining our area. So when x is 0, a is going to be 0 because 6 times 0 is 0, take away 0, 0 again. All right, so when that, in a real life sense, that means that when the garden length is 0, the area is 0, of course. Okay, when the garden length is 1, 6 times 1 is 6, take away 1 squared, which is 1, that gives us 5. Okay, 6 times 2 is 12, minus 2 squared is 4, so 12 minus 4 is 8. 3 times 6 is 18, minus 3 squared is 9, so 18 minus 9 is 9. 6 times 4 is 24, minus x squared, so 4 squared is 16. So 24 minus 16 gives us 8. Now what you notice here is our values are starting to mirror. Okay, so we'll put 5 into our equation, but we'll see, I bet you anything, that next value is going to be 5, okay, because parabolas are symmetrical. So 6 times 5 is 30, minus 5 squared, which is 25, so 30 minus 25 gives us 5, all right? And hopefully you can trust the process and know that is 0. 6 times 6 is 36, minus 6 squared is 36, which gives us 0, okay? So, important to note, a parabola will always be symmetrical. Now this table of values gives us a nice symmetrical parabola about the center value that we've been given. That doesn't always work out. If you don't have symmetrical values, you just need to take some more values either before you've started or after you've started. Okay, but you will always have symmetrical values. So draw the graph of a equals 6x minus x squared from the table of values. So we have experience with this. Hopefully I can fit it all in. My graph is a bit big compared to my table of values, but that's okay. We have x values of 0, 1, 2, 3, 4, 5, and 6. I don't quite have 6 on there, but we will deal. Okay, so when x is 0, a is 0. So this is my a. Okay, instead of y, I've got a. So 0, 0, 1, 5, 2, 8, 3, 9, 4, 8, 5, 5, and 6, 0, but that's okay. Now, it's really important to note a parabola is a curve, okay? So please don't use your ruler to join the points. You need to try and use a smooth curve where possible, okay? So we're going to join those points up as best we can, freehand. Look, it's not going to be perfect, but we'll do our best. Alrighty. So that's what our parabola looks like. Okay, and in terms of the question being the area of the garden bed, this is the point where we're going to get the biggest area of the garden. Okay, so we'll just have a look at our next question, which is use the graph to estimate the area of the garden when the length is 4.5 meters. Okay, so we have our parabola here. When the length is 4.5 meters, it's going to be halfway between 4 and 5. So if we take that up to meet our graph and then take it across here, okay, you're going to get, as we said, it's an estimate. We're going to get a value of about 6.5. So what that tells us, if the length of the garden bed is 4.5 meters, our area will be about 6.5 square meters. Okay, so we say when x equals 4.5, a is approximately 6.5 square meters. Okay, so it's just a matter of being clear about what you're talking about. Don't just write 6.5, okay? Say what it is that you're saying. All right, so what's the maximum area of the garden? As I said before, the maximum area of the garden is where A is at its highest value. So the highest value that we have of A is 9. So that is going to be the maximum area of the garden. Max area equals 9 square meters. Okay, and what is the garden length in order to have the maximum area? So remember, our garden length is represented by x. So when our A is at its highest value, our x is 3. Okay, so length when you're writing in the wrong color, area is maximum x equals 3 meters. Okay, hopefully that's helpful for you. Give it a like if it was. Let me know if you want me to cover anything else, but as always, subscribe to my channel so you get notified when I upload new videos.